What you see on your screen is an Excel, and I made this for solar computation. And in this video, I'm gonna show it to you how I use this one to size a solar system. Like for example, here I have a device list, and also I have here a battery parallel mode, also battery series parallel groupings mode here. And on this side, I have also battery series groupings mode for milliampere. Here is for ampere, and I also have here for solar panel parallel mode, and I also have here for solar panel series parallel groupings modes. If I have many solar panels, so I need to groups because of the inverter specs. And also I have here breaker rules, no, for computation breaker rules. And also I do have here for how to get the ampere and wattage, and also for the aircon horsepower, how many watts. Like for example, if I have 1 horsepower, how many watts? 1 horsepower. We do have 746 watts for 1 horsepower aircon, and for 2 horsepower, we have for 1492 watts for the aircon of 2 horsepower. And also I have here what is the cost of your system, the overall system cost it shows here, and you can see the average energy consumptions per day by putting the data here, like for example the rated cost in your place, and also your energy consumption a day. And also I have here actual bill. If you receive actual bill coming from your electricity, you can put here the actual energy consumption, and also for your monthly bill. And if you only have information about the cost of your monthly bill, you can put here. And of course, you must know what is the rated cost in your place in order to get the actual monthly energy consumption. Okay, so we have some many options here, and let me start. And as basic for the device list, like for example, if I have TV 60 watts and electric fan, or let's say ref 300 watts, all you need to do is just put your devices here and get the wattage. And I have washing machine, for example, 500 watts washing machine. And for the lights, overall total, I can put here, like for example, 10 lights with 10 watts each. I put here 100 watts. And now I already get the overall total power. This part is automatically do the sum, and we get the overall total power of 960 watts for all of these devices. And of course, like for example, if you are using the rice cooker, like for example, you have 500 watts rice cooker. So rice cooker is not all the time is using, and for rice cooker you can use like 3 times a day, and rice cooker can cook food, can cook rice within 30 minutes. So we must get the nominal wattage of the rice cooker or the usage hours. If I use this rice cooker for 3 times a day with 30 minutes, I can compute it here to get the average load watts summary. So I'm just gonna give an example. The rated watts is 500, and I'm getting this average load watts because rice cooker we cannot include this in computation to our regular devices. So because we are not using it all the time, so that's why I need to get the average load watts summary. Okay, so we do have for the rice cooker 500 watts, and the estimated time that we are going to I'm using it for 3 times a day. This is the standard usage of the rice cooker. And if we compute that time, 30 minutes times 3 equals 1.5 hours. So this rice cooker we can use, the usage time is only 1.5 hours, and we got average load watt summary 47 watts. So I will remove the rice cooker 500 watts, and I put here 47 watts. So this is what I am doing the calculation. If I get the summarize of the device list, just to get only the wattage of each devices and put it here. And for the washing now, we have here washing. We are not using it all the time. We only use like maximum or minimum 3 hours only. So I can do also get the average load watts only, and I put it here 500. And for the usage time is 3 hours, and we got 94 watts only. So I will remove the washing machine wattage. Just put 94 watts here. And the final overall total power that we have for all these devices is 601 watts. And then the next thing to do is what is the usage hours time to get the energy consumption a day. So here we have standard time, and our standard time is 16 hours. I'm just gonna put here 16 hours. And for the standard time using of all of these devices, we have energy consumption a day of 9,616 watts hour. And of course, we have here for the battery rolls, which is half of our power consumption a day, 4,808. It's automatically do the total. And of course, where did I get this 16 hours standard time? So we have to go to our standard time. We have clock here and our standard time computation. In one day, we have 24 hours. And of course, we have sleep time. And our sleep time, regular sleep time is 8 hours. That's why we get the total hours of 16 hours. Okay, so we go back to our device list. Now that we get our usage time, which is the standard time is 16 hours, and the total of our energy consumption a day now is 9,616 watts hour, and we get the half of the total of our power consumption a day for the battery rules. So we also have here this usage hours for off-grid. I'm using it if someone asking me to compute their devices for off-grid system. So usually off-grid system is running 24 hours. And also we have here for the battery rules, and we have to get this the half of our power consumption, energy consumption a day. And to get that, I am going to divide this into 16. So I'm gonna put it here 8 hours, and I now have 4,808 energy consumption based on the battery rules. Our next step here is to get the battery. What kind of battery capacity you wish to use? So battery capacity, we can put the battery capacity here so that we can get the estimated battery quantity over here with the dip of discharge and inverter factor. So whatever I put capacity, it will automatically give the total for the estimated battery quantity for its energy consumption a day. Okay, you can put here, like for example, 100 Ah. If you put 100 Ah battery capacity on this line, it will give you estimated batteries required for the energy consumption a day. Like for example, for the 24 hours, we have 17 batteries, and for the standard time, we have 11 batteries, and for the usage of battery rules, which is 8 hours, we have 6 pieces batteries. So you can change this battery capacity. You can make it 200 Ah. For 200 Ah, our battery quantity here is decreasing. If I use this 250 Ah, so the battery now is for the 24 hours of usage of grid is 7 pieces. For the night time, this one is night time now, standard time. Also, I call it night time. And we have 4 pieces batteries. And for the battery rules, which is 8 hours, we have 2 pieces battery. So this is the easy way how to get the required batteries for your overall total power. And it automatically gives you the total. Actually, we can get also the battery life. Like for example, in 24 usage hours, we have 7 batteries here. And let's check what is the battery life of that 7 batteries. 7 batteries with 12 volts, and the ampere hour is 250. So for 7 batteries with 250 connected in parallel, we have 21,000 watts hour. And this one is enough to supply for our energy consumption, which is 14,424 watts. And yes, of course, I have here, because we have a lot of batteries, we can do the groupings mode. Let's go over here for the groupings mode. And you can choose here your system, whether it is 12 volt system, 24 volt system, or 48 volt system. So my advice here is 48 volt system. Bigger volts is can handle more heavy loads. Okay, so to get the 48 volts, you have to series the battery, 4 pieces batteries with volts of 12, and the capacity is 250. Now we have system volts 48, or if you planning to get the 24 volt system, make it 2 series batteries. and you now have 24 volt system. So let's go back to 48 volt system for batteries. And of course, the requirement is 7 batteries. So what we need is to have a groups of batteries. So let's group one, and we get the overall battery quantity 4 pieces, and we have to group two, and we now have overall battery quantity to be used, which is 8 pieces battery. Meaning we have to add another one battery to the estimated battery quantity to get the equal to get the balanced battery, because we can actually group the batteries if the batteries are not complete. So we need to add one here to make it 8 pieces, or you can reduce it, you can make it 6 pieces, the batteries. For 6 pieces batteries, 48 volts cannot be, so you have to go for 24 volts. 24 volts, and you have another group, 3 groups, and you now have 6 batteries. So it depends on your budget, but for me, I'll go with a 48 volt system with groupings of two, and I get 8 batteries. And our battery capacity in series parallel, we have 500 ampere, and the maximum current here is already shown 125 ampere. Okay, so let's check the battery life. Like for example, we have 48 volts and 500 capacity. Let's check what is the usage sign or the battery life. 48 volts and capacity is 500 ampere, 500 Ah. And we do have here a factor that already applied, battery discharge factor, 80%. And for the the inverter, my spelling is not correct. I'm gonna change it inverter. Okay, inverter. Okay, let's continue. Inverter conversion also applied on this battery. And of course, we have to get the nominal power load. Like for example, we have 601 watts. So we are going to make it like 600 or 500 nominal load. And for that load, we have 29 hours. Well, we have 29 hours of usage. And let's follow the estimated battery, what we have got here for the 250H. Let's say what is the usage hours. 250, let's check here. 7 batteries, so we have 1750 Ah. 12 volts, 1750 Ah. 12 volts, 1750. Yes, we got 25 hours, almost the same. And here we have 4 pieces batteries, 4 pieces batteries, 4 pieces. And for 4 pieces batteries, we have 12 volts and 1000 Ah. 12 volts, I'm gonna make it is 1000. 1000. So we have 14 hours. So almost near to the usage hours, our usage hours. And of course, we can check the wattage of that for batteries. We have 12,000 watts hour compared to our energy consumption of standard usage time. Now the next step is what is the panel? How many numbers of panel that required for this energy consumption? Okay, we have to base in our standard time to get the panel quantities. So let's go to the panel, get the panel quantitative panel based on monthly energy consumption. So we are going to use this part to get the panel quantity. And according to get the panel quantity, we need the average monthly energy usage. And of course, for the peak sun hour in the area and the days, and the panel watts you wish to use. So in this part, average monthly energy usage, we have to get the standard computation, and our standard computation for that standard usage, our monthly energy consumption is 288.48 kilowatts. So I'm gonna put here 288.48 kilowatts. And of course, the peak sun are in your area. Like for example, you have peak sun are in your area 8 hours, 6 hours, 7 hours. But at this time, I'm gonna put like 6 hours, and I will just compute it for 30 days. Um, for the panel that I want to use this, actually you can use this like 100 watts. It's up to you. But if you use smaller watts, you can get the more panels. Unlike if you are using higher watts, you can get less panels. So if you are using 100 watts panels, you can get 20 pieces for the your monthly energy consumption. And of course, no, I already apply here with a less factor of 20% because panels have a lot of factors. And let's try 200 watts. For 200 watts, the minimum required panels is 10 pesos. For the 500 watts, let's say 500 watts, the minimum required panels is 4. And for the 590 watts, like for example, 3 pieces. So this is how I get the numbers of panels. And of course, we can check the wattage of these panels. So 590 watts, 3 pieces. Let's go to our panel. 590 watts, 3 pieces. 13 ampere. I have 52 VOC. 590 watts. How many solar energy consumptions a day? So here we're gonna put 6 hours. Sorry, 6 hours. And we have 8,496 watts. You can add more panels here depending on your inverter specs. So I'm gonna show it to you what is the use of our solar panel series parallel grouping mode. This one is the same like the battery, and we need to get the total volts for the inverter specs because our inverter specs the volts. Like for example, the maximum volts of PV input of an inverter is 500 volts. So here we can get the volts. Like for example, if we have more panels, like 20 panels with 13 ampere and VOC is 52. Our total volts in series is 1040, and this 1040 cannot be connected to inverter because our inverter specs is only 500 volts. That is the maximum, and we must have lower than that maximum volts of the specs. So here we can adjust the number of panel in series. We can make it 10. So for the 10 panels in series, we still have not get the correct volts for the inverter. We have 520 volts. We have over 20 volts. So we have to reduce our panels. We make it 9 pieces panels. Now we have 468 volts for the 9 series in panels. So this volt is okay for the inverter specs, which is the maximum volts PV input of the inverter is 500 volts. And here we have to make groupings. For one group, we have 9 panels. For two groups, we have 18 panels. So the panels that we need is 20 panels. Actually, we can adjust this. We can make it 8. And here we can add another groups. So now 24. We can reduce that 5 and make it 4. Now we have 20 panels. Actually, getting panels here is not for the quantity. We need to get the solar panel generation charge a day. This factor what we did on this part. So this part, this part is only an example how you get the specs on your inverter. So now that we have already our data, so we have overall total power, and we have the numbers of batteries for its usage, like 24 hours, standard time, 16 hours, 8 hours, and we get the estimated battery quantities here. So our system is almost complete. So it will be easy for you to choose which inverter, which panel you want, and what kind of batteries you need. Okay, let's go here for the actual energy consumption. So this is how I'm using this. Like for example, we have already actual bill, and our actual bill, the actual energy consumption is here. So what I'm going to do is just to put that actual power consumption on this part, 288.48. And then of course our monthly bill, you need to put the monthly bill. But here we don't have an idea how much our monthly bill. So I am going to use this part. Okay, energy consumption a day in watts. So we have to get the standard time for our energy consumption, which is 9,616 watts. So I'm gonna put here 9,616 watts, 9,616 watts. And of course, we have to put our rated cost in our area. Like for example, in our country, I'm living in our province, and we have 12 pesos per kilowatt. And my billing is estimated amount cost per day here, 115 pesos point 39. Estimated amount per month is 3,461.76. So here we can get the monthly bill. So I'm gonna use it here. Monthly bill. My monthly bill is 3,461.76, and we get the same rated cost per kilowatt hour, which is 12 pesos. The same on this side, and also we already have get the same average energy consumption a day. It's same on our actual energy consumption a day or our computation for the devices. And of course, we already get the average low power load watts, which is 601, and the same here, 601. Wow. So this is how I made a computation. And here we can get also the same monthly bill. Like for example, your monthly bill is here, 3,461.76. And your rated cost in your area, in order to get the actual monthly energy consumption, you need the monthly bill and the energy rated cost in your area. And the rated cost is 12 pesos. And our energy monthly consumption here is already shown, 288.48, and it's the same. It's the same. And I'm just want to add, let's go back to our device list. I also have here how to get the required breaker. Like for example, I have an inverter. We go to conversion of the ampere. This is for the conversion of the ampere. So I have, like for example, I have system inverter which is 10,000 watts, 10,000 watts or 10 kilowatt, and I am using 48 volts battery. Here we can get the ampere of our system for the 10 kilowatt inverter and 48 volts. And for the breaker, we have to, based on this total ampere that the total we get, and we need to apply the breaker rules here, because if you are using the same ampere breaker, it will automatically trip off without any reason because of our breaker rules. So let's go to our breaker. Here is our breaker, 208.33. 208.33. Here are breaker rules not to exceed 80% of its capacity, meaning your breaker rated ampere, like for example, you have 20 ampere, this breaker cannot handle 20 ampere. It can handle only 80% of load. So here we have 288. Sorry, let's go back. I forgot ampere. 208.333. 208.333 ampere, or 208. We can say that. What is the breaker that we need to use for this ampere? Okay, so we need 260 ampere or at least 250 ampere. Now let's go back to our device list. And so for this computation, almost done. The next thing you need is to get the equipment. Yes, the equipment. And of course, we have here system runtime. I applied it if I get some details, like for example, the prices of its equipment. Equipment is here. So the total is here automatically. Shows with labor, no labor, no labor, with labor. Like for example, no labor, with labor. Device this, and the system runtime, I use it to compare how many years that we can get the value, or what you call this, I don't know what's the word, but you can see it here. I am going to calculate with labor, no labor, with labor, and I can put here the batteries, like for example, our battery, our standard computation for the battery is 4 pieces batteries, and it will automatically including the total here. Yes, and the panel 3 pieces, or I'm gonna make it 4 pieces. Yes, this is the total, which is 115,149, and I can put the year here. And let's say 1 year. We have system run 41,000 for 2 years, 83,000 for 3 years, 124. So for 3 years, we already get the our system overall expenses, or we already overcome, and we almost paid, no, something like that. I don't know the words, but I'm trying. Hope you can get some idea regarding this computation, and if you do have like request for how to calculate your system, just leave your comment down below and we'll see. Okay, so thank you so much for watching, and God bless us.